My name is Elizabeth Lunar.
My name is Divya Chaudhary.
My name is Kazai Fernandez.
And my name is Shiru Choi.
Imagine, you are on the lunar South Pole with a partner. Once you set up, you volunteer to head out exploring while your partner stays back at base. While exploring, you weren't paying attention to your surroundings. Tripped, fell, unconscious, everything went black. Your partner back at base realized you've taken way too long and has to send a rover to your rescue.
That's our mission. Our mission is to design and develop a rover that can save an incapacitated astronaut on the lunar South Pole. To do this, we need to face a series of challenges and get over those challenges as well.
One of the challenges we will be facing on the lunar South Pole is the lighting, because some places on the lunar South Pole are dark 24/7, but on the other hand, some are light 24/7. So we have a built-in light that turns on in the dark and off in the light.
Another challenge our rover will face is the rough terrain of the lunar South Pole. To avoid crashing into big boulders, our rover will use its obstacle sensor to detect and go around the obstacles.
And it's not just that. Another problem our rover will face on the lunar South Pole is the lack of atmosphere. Why is this a challenge, you may ask? Is that sound needs a medium to travel in. On Earth, that medium is the atmosphere, but the moon doesn't have an atmosphere. This means we can't use our ultrasonic sensor, so we are using our infrared sensor instead.
There's also the problem of radiation. Radiation can cause electronics to malfunction, so we will cover the real rover in gold foil.
Now we will show you our demo.
This is the home base beacon, or the landing site.
This beacon represents where the astronaut has fallen. The beacon will send infrared signals to our infrared sensor to tell the rover roughly where our astronaut has fallen.
Now we will start the program so our rover can save the astronaut.
First, it takes wide spins to get into the field of view of the beacon. Once it does, it starts taking smaller turns so it can align with the angle tolerance of plus and minus 1.
Now it has detected the beacon and is going forward. It also detected an obstacle in the way, so it's avoiding it. As I said before, this is the light that turns on in the light and off in the dark. Now it is realigned to the beacon and is going toward it. It is making sure that it is there.
It's found the location of the fallen astronaut.
It has now picked the astronaut up and is making sure that the astronaut is on there. And now it is going back to the home base beacon. As seen before, it is taking big turns and small turns once it gets in the field of view.
The rover is stopping and realigning so it aligns properly. Now it has successfully reached the home base beacon.
During this project, we learned
How to apply problem solving when it comes to a bug in our rover.
rover suspensions like 3-bogey and rocker bogey,
How to program my blocks and variables.
And how to apply mathematics to solve problems like how many wheel turns we need to use to cover a specific distance.
Thank you.
Any questions?